This is page 335. This is the lesson 12.1 independent practice. For 10 through 13, use the coordinate plane shown. Each unit represents 1 kilometer. So number 10 reads, write the ordered pairs that represents the location of Sam and the theater. So we're going to have two answers here. So we start with Sam because that was the one listed first. And what are the coordinates for Sam? Well, to get from the origin right here to Sam, we would be going 1, 2, 3, 4 spaces to the right. So it's going to be parentheses 4, comma, and then it's 2 spaces up. And since we moved to the right, the 4 is positive, and since we moved up, the 2 is positive. So Sam coordinates are 4, comma, 2. And then we're supposed to do the theater as well. The theater is located, it's to the left, so I'm going to go 1, 2, 3 spaces to the left. That means -3. And then it's up 1, 2, 3, 4, 5. You can go over here and see that it would be on the 5. So the reason why the first one's negative is because we moved to the left, and the second one's positive is because we moved up. Alright, so number 11 reads, describe Sam's location relative to the theater. And one thing we need to do is we need to recognize that the directions are that each unit represents a kilometer. So every time I move, I'm going, each space I move, I'm going a kilometer. And we also need to know the compass rose right here. And I realize that goes off the video, but that's okay. Up would be north, to the right would be east, to the left would be west, and down would be south. All right, where is Sam compared to the theater? Well, Sam is lower down on the graph than the theater, so Sam is to the south. How far is Sam to the south? Well, we're going to count 1, 2, 3 spaces down. That means 3 kilometers. So we're going to say Sam is 3 kilometers south. But that's not it. He's not just directly 3 kilometers south. He's also to the, besides being to the south, where is he? So I'm going to put and I'm going to count from here over 1, 2, 3, 4, 5, 6, 7. So Sam is 3 kilometers south and 7 kilometers east of the theater. All right, let us move on. I'm going to have to erase these answers and scroll up. We're on now 12 and 13. 12 reads, Sam wants to meet his friend Beth at a restaurant before they go to the theater. The restaurant is 9 kilometers south of the theater. It doesn't say anything about being east or west, so if we know it's 9 kilometers south of the theater, then we just count down 9 spaces. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. It's right here. I'm going to put in an R for a restaurant, and really I should probably erase the rest of those dots. I was using those dots to count, but they don't really need to be. They might just distract me, so I'm going to erase them all. Okay, so let's read the rest of the question. Plot and label a point representing the restaurant. What are the coordinates of the point? Well, we plotted the point, we labeled it with an R, and now what we need to do is figure out its coordinates. To do that, we go back up to the origin, and then we go left and right first. We go left 1, 2, 3 spaces. And we go down from the axis, we go down 1, 2, 3, 4 spaces. So did we do everything? We plotted the point, we labeled it with an R, and we put the coordinate points right there. It's -3, -4. All right, Beth describes her current location. I'm directly south of the theater, halfway to the restaurant. Plot and label a point representing Beth's location. What are the coordinates of the point? All right, so she's directly south of the theater, so she's in here somewhere. I'm going to draw a line. She's in here somewhere because she's south of the theater, and it says she's halfway to the restaurant. That means she's halfway between the theater and the restaurant. So let's go back up to the theater and the restaurant and figure out how many points apart they are. They are 1, 2, 3, 4, 5, 6, 7, 8, 9 points away. So what's half of 9? Well, if you take 9 and you divide it by 2, you get 4.5. 4.5 is the same as 4.5. So how do we figure out where she is? Well, I'm going to count. Instead of counting up to 9, I'm going to count to 4.5. 1, 2, 3, 4.5. She's right here. That's where Beth is. I'm going to put a B for Beth. And what is that point? Well, she is to the left 1, 2, 3 spaces to the left, which makes sense because we kind of knew she was 3 spaces to the left because it says she's directly south of the restaurant. And then is she up or down? She's up, so we're going to do a positive number here, but she's not up a whole number. She's up just half a number, so I'm going to put 0.5. So her coordinates are -3 and then positive 0.5. Okay, good job. We're done with the first half of the page. Let's move on to the bottom part of the page. For 14 through 15, use the coordinate plane shown. Find the coordinates of T, U, and V. Might as well just go in order. T's coordinates are, T is to the right 1, 2, 3 spaces, but I was gonna mess that up, but they're not labeled. One thing we have to do is figure out exactly how this is supposed to go. So I think what I'm gonna do is actually zoom in a little bit and help you identify how these are labeled. So if this one right here is 1, this would be a half. What's a half of a half? This one right here needs to be 0.25, and this one needs to be 0.75. So what we're basically going to notice, it's almost like it's just going up by quarters. Each of these would be a quarter. So this would be 25 hundredths, 50 hundredths, 75 hundredths, and 1 whole. So that's going to really help me as I answer these questions. So find the coordinates of T. T's coordinates are, T is over to the right 75 hundredths, and then T is down, so I know it's a negative. I haven't counted yet. Actually, you don't even have to count. It's just right here on the negative 1.0. Negative 1 or 1.0. There's T. All right, where is U? U is to the right, and it's to the right 75 hundredths again, so I'm going to put positive 75 hundredths. The difference between U here is my second number is going to be positive, because when I go to the right and then I go up, both numbers are positive. Now, how high up is it? Well, what's going to be 1 past 1.0? Remember we said they're going up by 25 hundredths, so it's going to be 1.25. So the U's coordinates are 1 and 25 hundredths. And now we're on the last one, which is V. V's coordinates are, I go to the left, and it's the same distance to the left as I was going to the right. It's 3 spaces to the left, but since it's to the left, it's negative, so it's negative 75 hundredths, and I'm writing that really messy. Oops, didn't want to do that. Negative 0 and 75 hundredths, comma, and then it went up, and it's a positive number, and it's the same number as we went up. See, it's on the same line as U. Well, if U is positive 125, then V is positive 125. We don't need a symbol if it's positive. All right, there's the coordinates of T, U, and V. Good job. Question 15 reads, points T, U, and V are the vertices of a rectangle. Point W is the fourth vertex. Plot point W and give its coordinates. You might not be familiar with things like vertices or vertex, but what you should be familiar with is a rectangle. And you may have even noticed that this would make a rectangle. So if you filled it in right here, clearly that's going to be a rectangle. It's asking you to find the coordinates of the fourth line of the fourth point. It's not labeled. It's down here in quadrant 3. It's going to be right here where those two lines meet. So if I can just state what the coordinates are, then I get the right answer. The coordinates of W are going to be negative 75 hundredths, 0 and 75 hundredths. Now we know that because it's the same as V. V is negative 75 hundredths, and so W is negative 75 hundredths. And then how far down did I go? I went to the left, so that's negative, and then I went down. I went down to negative 1.0. Cool. That is the coordinates of point W. All right, we are on number 16. Number 16 is explain the error. Janine tells her friend that ordered pairs that have an x-coordinate of 0 lie on the x-axis. She uses the origin as an example. Describe Janine's error and use a counterexample to explain why Janine's statement is false. Now you might look at that and think, oh no, she's right, but I want to show you why she's not. So the key reading right here. Ordered pairs that have an x-coordinate of 0 lie on the x-axis. So an x-coordinate of 0 would look like this. 0, comma, and she used the origin as an example. So she did this. She said 0, 0, 0, 0 would go here. Look, it's on the x-axis. See, look, it's on the x-axis. Well, it's an invalid example. What she should have done was not chosen the origin. She should have chosen 0, 5 or something like that, or 0, 3 or 0, 1, anything like that. So I'm going to put 0, 3. And let's just pretend that I'm going to go ahead and blot these out for a minute. Let's pretend, for the purpose of this example, let's pretend we're just going up by just once, okay? So I'm pretending that 0, 1, 0, 1, 2, 3, 1, 2, 3, negative 1, negative 2, negative 3. All right, so where would this be? Over 0, up 3. Over 0, up 3 would be right here. Is that on the x-axis? Over 0, up 3? No, it's on the y-axis. So, what's her error? If the x-coordinate is 0, that means you go over 0 and then up or down whatever the y-coordinate is. That means the point will be on the y-axis, not the x-axis. So we can actually draw a conclusion here. If the x-coordinate is 0, then that point is on the y-axis. If the y-coordinate is 0, then it's on the x-axis. Okay, finish up here number 16, and then you will be done with page 335. Good job.